Hello friends, welcome to our channel Instrumentation Technical Studies. Let's start our today's topic, bimetallic temperature gauge. Before going to our topic, let's discuss the basic molecular behavior in every matter. Normally, every matter is made up of molecules that are in constant motion. The motion of the particles is oscillatory, so it is having both amplitude and frequency, and these two parameters are directly proportional to temperature change. As we discussed earlier, the frequency and amplitude of oscillation of molecules are directly proportional to temperature. But in our topic, amplitude of oscillation is very important. So we will go further into amplitude point of view. Carefully observe the diagram. In the first, the temperature is low, oscillation amplitude is low, and also the size of the material is low. And, as the temperature increases, see, the oscillation amplitude also increases, followed by size of the material. So finally, as the temperature increases, the size of the material increases, which is known as linear expansion. Linear expansion can be measured by using the following formula, where L is length of material after heating. L0 is the original length of material. Alpha is coefficient of linear expansion. Delta T is the change in temperature. So, here we can measure the change in temperature by using two elements. One is by using coefficient of linear expansion, and another is by using the length of the material. Temperature measurement by using coefficient of linear expansion. The value of alpha can be varied from material to material. Some of the coefficient of linear expansion values can be seen here. The figure shows the bimetallic strip. It can be constructed by adding two metals, metal A and metal B, and one side is fixed. But here the important point is, both metal A and metal B are having different coefficient of linear expansion. In this example, metal B expansion coefficient is less than metal A, so whenever temperature is applied, it will bend towards lower expansion coefficient metal side, that is metal B side. So, pointer and scale is designed for this to indicate the particular temperature. See the diagram. In this type the deflection is good, but the amount of deflection over a temperature range is very small, which can affect the sensitivity, that is, we cannot get the small changes in the temperature. For this reason, we go for increasing the length of bimetallic strip. Increasing the length of bimetallic, to increase the sensitivity. In this type, the length of bimetallic rod is very large, and can be wounded in the shape of spiral. By this it can show the small change in temperature, but it has a defect in industrial use. Check the real diagram of spiral wound temperature gauge. It doesn't contain an immersible tip for the measurement of material in the pipe. Helical wounded bimetallic temperature gauge. In this type the bimetallic is wounded in the shape of helical, and the bottom side is fixed in the edge of the tip, and the upper or movable end is fixed to the pointer. So, by using helical-shaped temperature gauge we can measure the temperature of the material in the pipe. Thank you for watching. If you like this video, please like, share, and subscribe.